Okay, so till now we have assumed that grouping of attributes into relation schemas is done either by the database designer, his intuition, or it is done by mapping of database schema design from a conceptual data model. Right? What I mean to say is that these particular attributes are grouped, or these attributes should be grouped to form a relation schema. How is it decided? We did it by mapping it from ER model to relational model, right? That these particular attributes should form a relation schema, right? If database designer doesn't go that way, then how he or she can group that? He or she can group the attributes to form a relation schema according to his or her intuition, right? So these two ways are possible. So how can we determine which grouping of attributes into a relation schema is better? Let us say the database designer comes up with this relation schema, right? That is the grouping of these set of attributes into a relation schema is good enough, right? So how can we evaluate that this design is better or this design is better? There is no way, right? We haven't discussed any of its way, right? We haven't developed any formal measure of appropriateness or goodness to measure the quality of relation schema design, right? So we need a formal measure to say that this design is better or that design is better. That is grouping of attributes to form a relation schema. This grouping is better or that grouping is better, right? So how can we do that? How can we measure that this particular relation schema design is better than the other one? For that we need normalization, right? So normalization, what it does is it analyzes the relation schema to meet certain requirements, right? And in case the relation schema doesn't meet certain requirements, then what we do, we decompose the relation schema, right, in order to meet those requirements. So that is normalization, right? It is to measure the quality of the relation schema or appropriateness, right? It is used to analyze the relation schemas, right? And also we have certain requirements to meet so that relation schemas are considered good enough, right? So the tool that will be used in the process of normalization is functional dependency, the concept of functional dependency. So what is functional dependency? Functional dependency is the main tool that we will be using to discuss or to describe the appropriateness of grouping of attributes, right? So functional dependency will aid in the process of normalization. So we have to look at both functional dependencies and normalization, right? So normalization procedure is what? It will perform a series of tests to relation schemas, right, in order to see whether it meets those requirements, and in case it doesn't meet, the relation schemas do not meet those requirements, then it will decompose those relation schemas, right? So that is normalization. So let us see what can be the problems, what problems can arise if the relation schema is not good enough, right? So we have two relation schemas, we have two models of relation schemas. Let us see which one is better and why, or what are the problems that we can encounter, right? So let us first talk about space. Space is an important resource, right? So we need to use it very effectively. So in order to use space, which one do you think will consume more space? This one or this one? This one will consume more space. Even though it has two relation schemas and here there is just one relation schema, this will consume more space. Why? Let's analyze that. Okay. So here what we are doing, for every department we are storing all the information pertaining to a particular department, right? Here the department number is 5, right? So we have stored the department name DMGRSSN of the department, right? So if there are 100 employees working for a particular department, then we will write DNAME and DMGRSSN 100 times. So this is redundancy, and redundancy leads to wastage of storage space, right? So storage space is wasted in this case, right? In this case it is not wasted. If 100 employees are working for a particular department, then what we will do, we will just write its D number here and we will not store its information again and again, right? The information is stored at one place here, right? Let us say here 2 employees are working for the department number 5. So information about the department number 5 is not stored twice, it is just stored once, right, in this particular relation, right? But in this case what is happening, the information about a particular department is repeated twice, or as many number of times as many employees are working for that particular department, right? So this is an example of redundancy. This causes redundancy and hence leads to wastage of storage space, right? So another problem caused by relation schemas can be update anomalies. What is anomaly? Anomaly is a problem, right? So update anomalies, right? So we already discussed that update operations can be classified into can be of three types, right? Insert operations, delete operations, and modify operations. Hence, update anomalies are of three types: insert anomalies, delete anomalies, or modify anomalies, right? Or I should say modification anomalies, right? The problems that can arise from these three operations, right? Or these three update operations, right? Let us see one by one what are these problems that are arising, right? So let us say we want to insert a tuple in this particular relation for a particular employee, right? So what we have to take care, let us say this employee also works for department number 5, right? So these are valid birth dates and addresses, right? So I just wrote dash here for simplicity, but these are valid birth dates and address. Let us say GHI is name and SSN is 324 something. Then if when I am inserting the values, right, I have to write information correctly for a particular department, right? That is, I have to write D number, then I have to write, I have to write research also, I have to write this also correctly, DMGRSSN, right? In case I fail to copy it correctly and I write 134 here, instead of 234 I write 134 here. That can happen, right? If I have to repeat this information for 100 tuples, then for every time we insert a new tuple, I have to see that this information is matching this particular information. Otherwise, what is happening, if I by mistakenly write this, what will happen? These two tuples have different values for DMGRSSN, so the values are inconsistent, right? So insertion anomalies, what happens is, as a result of insert operation, there is a problem of inconsistency. There can be a problem of inconsistency, right? So that is one of the problems. Again, if I have to insert a tuple, then it will see then there is a problem whether this value is correct or this value is correct, right? So the data has become inconsistent, it is not correct, right? So that is one problem caused by insertion. Let us talk about another problem. Let us say in this case there is no such problem, right? If I have to, if many employees are working for the same department, I will write just D number 5. I do not have to worry about whether this information, I do not have to repeat this information, so there is no need to worry about copying the values exactly or rightly, right? So there's this information just stored at one place here, right? So there's no problem in this case, right? In this case, there can be a problem of inconsistency while copying values, right? So now let us say I want to insert another tuple in this particular relation, and this tuple contains information about a department. Let us say the company has now had a new department and this department doesn't have any employees assigned to it yet, right? So what I should write, I want to insert information about department. Let us say department number 6, and let us say admin is the name of the department, and MGRSSN, let us say MGR is assigned to it. Let us say 364. Employee with social security number as 364 is the manager of this particular department. Then since no employee is assigned to this particular department, I should write all this as null, right? So the insertion of null values lead to a problem. Why? Because in this particular relation schema, SSN is the primary key, right? And according to entity integrity constraints, primary key value cannot be null, right? So this leads to violation. This causes a problem. And let us say after some time, if there is some employee assigned to this particular department, the first employee of this particular department, and I want to insert its information here, right? Employee and its corresponding information, then this tuple is not needed, isn't it? This tuple is not needed now, and this needs to be deleted, right? So such problems occur when the database schema, when the relation schema is not good, or the quality of relation schema is not good. Here such problem is not occurring, right? In case I have a new department that does not have any employees assigned to it, I can just simply write 6 admin and 364 here, right? No need to specify any values here, right? Whenever new employee comes up or new employees joins this department, I will write the corresponding information here. So here there is no problem, right? In this particular option there is no problem. Here there is problem, right? So that is caused by insertion. That is, there are two types of anomalies: insert anomalies. So two anomalies we saw, right, in under the insertion anomalies. First, while inserting employee tuple, and second while inserting a department tuple, right? So here these tuples are different, so there was no problem here. Here there is problem, right? So now let us talk about delete anomalies, right? The problems that that occur as a result of performing delete operations, right? So let us say I want to delete information. I want to, let us say there is only one employee. What is the name? DEF, okay, 315, and some birth date, address, and department number is, let us say HR. Let us say, so only there is just one employee in this particular department, right? So in case I want to delete this tuple from this particular relation, let us say the employee is fired, then what will happen? The information about the department is also lost, right? In case there is only one employee in that particular department, or the information about a particular department is present only once in the relation, then what happens if I want to delete this particular employee tuple? This information is also lost, right? So this causes a problem. Here it will not cause a problem. Here, if there is an employee who works for a department number 7, and even if you want to fire him, you can fire him. No problem. Here the information is already present if it has already been present, right? So it will not cause any problem in this case. In this case, it is causing a problem because we have stored all the information at one place, right? Now let us talk about modification anomalies. Again, in modification anomalies, the same kind of problem that we face during insertion anomalies, right? So let us say I want to insert, I want to change the value of DMGR SSN for research department as 136, right? So for all the tuples, all the employee tuples that work for department number 5, I have to see and I have to change the value of DMGR SSN to 136. In case if I miss even one tuple, what will happen? Again, the data becomes inconsistent, right? So inconsistency is a big problem here, right? So that are the problems that we encounter if the relation schema design is not good, right? So relation schema design needs to be good, and in order to analyze whether the relation schema design is good or not, what we will use? Normalization, right? So that is about it. And also there can be a problem of null values, right? Let us say I group a lot of attributes together in a single relation. Then what will happen? Let us say I include information even about employees or any, let us say I just, okay, let me just not do it like this. Okay, let us say I group a lot of attributes together in a relation, right? So all the attributes will not apply to all the tuples, right? Since I've grouped a lot of attributes together, all the attributes might not apply to all the tuples, then the values will be nulls. A lot of null values will be present. So null values also cause a lot of problems that we will discuss. So null values have to be dealt in a very different way, and we should avoid null values as much as possible, right? So null values also create a problem. So we should not have a relation schema that has a lot of null values, right? Or that causes a lot of null values to be entered into a relation, right? So null values is also a problem. So these are the problems that we can have when relation schema design is not up to the mark. Now let us discuss functional dependencies in the next video, because I do not want to rush much into it. Okay, so let us look at it in a separate video. Okay, so this is it for this video. Hope you like this. If you do, then please don't forget to press the like button, subscribe to my channel for more such videos, and I'll see you in my next one. Bye.